Today we're talking about rational coefficients and one-step equations. So when you are doing an equation, remember you have to keep each side balanced. So you can draw these lines here to keep them separate on both sides. And whatever you do to one side, you have to do to the other. So for example, if you have x plus 6, you're taking 6 away from both sides to keep it balanced. And that way you can get x alone, and that equals 4 minus 6 is a negative 2. You can check your work by plugging the negative 2 in for x, adding 6, and when you do this, you know 4 equals 4. Notice how I showed all of my work. Please write this down in your notebook. If you need to pause, go for it. On this one, we're going to draw our lines to make sure that we keep it separate. We're taking 8 away because it's a plus 8. So we're taking 8 away on this side as well. This cancels out and we're left with b. The reason why we want to do this is to prove that b in this case is going to equal a negative 13. These are inverses, so they cancel each other out. So if we plug in this equation, a negative 13, we can prove that negative 5 does in fact equal negative 5, and so it checks. Go ahead and try these, and I'll be back in just a second to show you what I did. Okay, so grab your red pen so we can check our work. Make sure that you drew your lines first, and then you're looking to see where your variable is, and you're going to take away any of the integers. So the opposite of a positive 6 is a negative 6. So we're taking away 6, and y equals 3. We can check our work by plugging in 3 plus 6 equals 9, and 9 equals 9, so it checks. Over here, the opposite of a positive 3 is a negative 3, so we're going to take 3 away from both sides. X equals negative 2. So if we plug in negative 2 plus 3, it equals a positive 1, and 1 equals 1, so it checks. On this one, we're taking away 4 from both sides, so we're left with a equaling a negative 7, and negative 3 equals a negative 7 plus 4, which negative 3 in this case does in fact equal a negative 3, and it checks. Let's look at these. This is subtraction. What do you think we should do with this one? Well, start with your line. And the opposite of a negative 2 is a positive 2, so we're adding 2 to both sides. So x equals 3 in this case. Let's plug it back in. 3 minus 2 equals 1, and 1 does in fact equal 1, so it works. Over here we have a negative 4, so we're adding 4 because it's the inverse. And r equals a negative 2. Let's plug it back in. Negative 2 minus 4 equals a negative 6. So negative 6 does in fact equal a negative 6. Because remember, same signs, keep them and add them. Okay, so go ahead and try these for me, and I'll be back in just a second to show you what I did. Okay, so check your work with a red pen. We're going to add 5 to this side and to this one, so we get y equals 9. And if you plug it back in, 4 does equal 4. Okay, over here you're going to add 8 to both sides, so you get x equals a negative 1. And if you plug in negative 1 minus 8, you get a negative 9. And negative 9 equals negative 9 is true. All right, what about multiplication? We have 4 times a number equaling 20. So what's the inverse of multiplication? We're going to divide by 4 on both sides. So x equals, in this case, 5. Let's plug it back in. 20 equals 4 times 5 is a true statement because 20 equals 20. Over here, we're going to divide by a negative 8, and so we get y equals a negative 3. So negative 8 times 3, but it's a negative, equals 24, and 24 equals 24. If I accidentally put a positive 3 here because I forgot to divide, you would see that this would give you a negative 24 equals a positive 24, and that's not right. What do we do on one like this? If z is negative, we can divide by a negative 1 on both sides and get z equals a negative 12. or you can just know that the opposite of a negative z would be a negative 12. Okay, so if you plug it in, again, just to check our work, a negative, this is a not, so it becomes a positive 12 equaling 12. Okay, go ahead and try these for me, and I'll be back in just a second to show you what I did. Okay, grab your red pen. Here is my work. I divided by 6 and I got 5 for x, and I checked it, and 30 does equal 30. On number 5, I divided by a negative 6 and I got a equaling also a negative 6, and a negative times a negative is a positive, and 6 times 6 is 36. On this one, I divided by a negative 9 and I got 8. I plugged it back in, and a negative 72 equals a 72. And on number 7, I divided by a negative 1 and I got y equals a negative 10, and a negative times a negative 10 is the opposite of that, so it's 10 equals 10. Okay, what about division? To undo division, we're going to multiply by the opposite, or by the number at the bottom. So these would cancel out. It's like having a negative 4 over 1. So a in this case would equal a positive 36. And if I would divide, I would know that this would also equal a negative 9, which equals a negative 9. Over here, I would divide, or I would multiply, because I'm dividing by 5, by 5. And when I multiply, I get m equals a negative 35. Don't forget to check your work like I did here. Okay, so go ahead and try these for me. Don't forget your lines. Okay, so I'll be back in just a second to show you the answers. All right, grab your red pen. We're going to multiply both sides by a negative 3, so I get y equals 24. If I plug that back in, I get a negative 8 equals a negative 8. Over here, I'm going to multiply by a negative 6, and that's a negative 180. And if I plug this back in, negative 180 divided by a negative 6 gives you a positive 30. So 30 equals 30. Okay, so that was our review. Now let's get to the nitty-gritty. We know the inverse property of multiplication is where you flip over the fraction, and so they can cancel out and give you 1. So here are some examples. I want you to pause the video and copy down this entire page for me. Okay, down here, remember to copy this down as well. The numerical factor of a term that contains a variable is called the coefficient. Remember, this is the coefficient and this is your variable. So in this equation, the coefficient is 3/4 c. All right, so to solve this, we multiply each side by its inverse. We flip it and we multiply. So, for example, if we have 3/4, we are going to multiply by 4/3, and when we do so, these cancel out to give us a 1. Remember, we want 1c, just so that way we can have c by itself. Over here, we would simplify the 3 with the 18 and get 6. So 4 times 6 is going to give us 24. Don't forget that we can also check our work. So just in case you're worried, you can always plug in the 24 and solve to know that 18 equals 18. Okay, go ahead and try these, and I'll be back in just a second to show you the answers. Okay, so we are going to flip this one over and multiply, and you are taking 1/5, and you're multiplying it. So there's nothing that we can cancel out. So 12 times 5 is going to give us 60. If you plug that back in, 1/5 times 60 is going to give us 12, because 5 goes into itself once and it goes into 60 12 times, and 12 equals 12. Over here we have to multiply by the negative, and it's 9/2. So when we simplify, we get d on this side, and then we get 2 and 4 simplify, so we get 2 times 9 is 18, but we're multiplying by that negative, so it's a negative 18. So let's check our work. oops, I almost put 81. All right. If we simplify 18, it goes into it twice. It goes into 9 once. So we get -4 over here. Oh, this was a -2. So just kidding. It's 4. So 4 equals 4. So on this one, you're going to work with mixed numbers. So you have a 1.5s equaling 16.5. So you're going to write the equation, and you're going to rename these into a mixed number instead, or excuse me, into an improper fraction from a mixed number. So you're going to take 1.5 and you're going to change it to 3 halves. How did I do that? Remember, you have one group of 2 plus 1. So it's called the C method. We take this one and we multiply it, and then we add on what we have. It's like having a pizza and cutting it in half and then having another half. So I have 3 halves. Okay, so what do we do with this? Well, now we can, once it's reworked, both of these, the 16 halves as well, needs to be reworked. So we take 16 times 2, which is 32, plus 1, which is 33. So I have 33 halves. Now I can get rid of the 3 halves next to the s by flipping it and multiplying. So this 2 cancels out, this 3 cancels out, and I'm left with 2/3 times 33 halves. So if we simplify, the 3 and the 33 simplify to 1 over 11, and the 2's cancel each other out. So this is gone, and we're left with s. We're left with 1 on both of these, and all we have is an 11 in the numerator. So 11 divided by 1 is 11. So my answer is s equals 11. Okay, you try this one, and I'll be back in just a second to show you what I did. Okay, so the first step in this is to take the mixed number and change it to an improper fraction. So 4 times 6 is 24, plus 1 is 25, and 3 times 3 is 9, plus 1 is 10. So we can rewrite this as 25 over 6 equaling 10/3 times c. So we need to multiply by 3 over 10, and when we do so, we can simplify. So I'm going to simplify the 3 and the 6 to 1 and 2. I'm going to simplify the 10 and the 25 and divide by 5, so I get 2 in the denominator and 5 in the numerator. So right now I have 5 in the top and 4 on the bottom. So c equals 5/4. Can that be left like that? No, we change it to 1 and 1/4. Okay, so that is our c. What about decimals? Okay, if it's a decimal coefficient, in the equation we have 3 and 15/100 equaling 45/100 times n. We do the same thing as if it was just a multiplication problem with regular plain old integers. So we're going to divide by 45/100, and when we do so, we get n equaling 7. Make sure you have your calculator for these ones because it's going to be really helpful. We also want to check our work, so plug in 7 times 45/100 and we get 3 and 15/100, so it works. Okay, why don't you try these two, and I'll be back in just a second to show you what I did. All right, grab your red pen. We are going to divide this side by a -1 and 4/10, divide this side by a -1 and 4/10. So when we divide a positive by a negative, we get a negative, so m equals a -1 and 5/10. If we plug this back in to check our work, we're going to plug in -1.4 times a -1.5 or 5/10, and when we multiply, we get 2.1 equals 2.1, so it works. Over here, we're going to divide by 7/10 on both sides. We're left with t equaling 7, and if we plug that in, we get 0.7 or 7/10 times 7, and that should equal 4.9 or 4 9/10, and that does in fact equal 4 9/10. So it checks. All right, that was a longer video, but hopefully the review will help you with the rational coefficients. See you next time.